Hello, I'm Kent, and I just wanted to make this video, hopefully it'll be pretty quick, explaining one of the more confusing things without using a whole lot of math for it, um, for a lot of consumers of science fiction, and that's how and why faster than light travel equals time travel. So, a lot of people who, even amateurs who are, or non-physicists who are interested in relativity have probably seen a diagram similar to this before. This is a Minkowski diagram. However, there's one thing that I've done on mine that probably not a lot of people have seen before, and that's that I've actually added in all the grid lines, all of the scaled grid lines for my moving frame, right? So this is my line that shows where the origin of my moving frame is, right? 0 meters. This is the 1 meter, 2 meter, 3 meter, 4 meter in that moving frame, right? These are the lines of where those positions are. And so notice, right, they don't intersect our rest axis, our normal graph paper axis, at the same place, right? Because of length contraction and time dilation and all of that. But so yeah, so I've filled in these grid lines, and I find that this makes it a lot more useful for people who don't necessarily understand the algebra behind relativity. You can do this graphically. You can even, if you look over the equations here and you substitute back in the values that I gapped out, like this u value and this x value. If you go back up here and you look at those, you can actually solve these mathematically and algebraically if you want to, just like you could on normal graph paper. You can find any arbitrary point on your moving frame and what that looks like on your rest frame, or vice versa, just by finding intersects of different lines within your coordinate frame. So that's one of the really nice tools about graph paper that I think that Minkowski diagrams normally don't have, and why this is so great. But so let's look at this, right? So let's look at a single faster than light signal. Now, a key thing to remember here is that every velocity that isn't the speed of light is going to be changed under relativity. So that goes for slower than light velocities, but that also goes for faster than light velocities, right? So I can make a faster than light signal that, say, travels at 7 times the speed of light. So it's going to go over 7 units and up of distance and up 1 unit of time in my rest frame, right? So you can see why I picked this point, because it's got a nice intercept right here. So, okay, so this is great, right? So this is my 7 times the speed of light signal. And immediately, by showing these grid lines, we can see that in my moving frame, I have started off at time equals 0, the time equals 0 contour, and I've actually gone back 1, 2, 3, 4 time units into the past. So this particular signal is actually, in my rest frame, it's going forward 1 second, but in my moving frame, it's going backwards 4 seconds as it travels through space. So this is bad enough, right? That means that in my moving frame, which could just as easily have been my rest frame, it means that now I have time travel. I have an effect occurring before the cause happens, right? And that's bad. As far as we know, physics doesn't work that way. So this particular line is out, right? But let's say, well, okay, so maybe it'll work though if I go backwards, right? So let's send a signal back at 7 times the speed of light. So if I go here, right, this is in my rest frame. I'm sending my 7 times the speed of light signal back towards my origin. And so we see, oh, okay, so I end up in the future in both reference frames, right? I'm slightly more than 2 seconds into the future in my moving frame, and I'm exactly 2 seconds into the future in my rest frame. So this is okay. But the problem here is that no longer can I say, or under physics, I can't just say that my rest frame is my preferred frame. There's nothing that says that I have to go 7 times faster than the speed of light in my rest frame again. What happens if there was a spaceship here that was moving at this, let's see, what did I pick? 60% of the speed of light, right? 0.6 light speed. So let's say that there was one flying along this line and it detects this signal seemingly out of nowhere, and it's confused by that, and so it goes to tell its buddy, right? So it sends a 7 times the speed of light signal. Well, that 7 times the speed of light is in its own frame. So it's going to go 7 distance units. So 1, 2, 3, 4, 5, 6, 7, right? Back towards the left. So that was this +1 meter line or +1 distance unit line. And then it's going to go forward 1 unit in time. So it's going to go from this line to this line. So this line at 1 forward is actually this point. So let's go ahead and fill that in. So that's going to be at -1, -3 in my reference frame. So okay, well, this is interesting now, right? Because now we have this ultimate receiving of a signal appearing spontaneously out of nowhere 3 seconds in the past, according to my rest frame, right? Before I've even sent the original signal, I have this signal spontaneously appearing in its own past. And notice, right, this is inside of its light cone, right? So this event here, even if it's only sending a light signal, can still affect the original sending event. And what's even more interesting to me is that this is 3 seconds in the past for the rest frame, and it's 1, 2, 3 seconds in the past for the moving frame as well, this particular point right here. They agree on when this event occurs. They don't agree on where, but they agree on when. And that's because I have traveled backwards in time in my moving frame with my original signal, and then I've traveled backwards in time in my rest frame with my moving frames faster than light signal. So regardless, even if this was just a one-directional signal, right? Pretend that I got rid of this original 0, 0 point and I just had this faster than light signal. It's traveling back in time in one direction, and that's not okay, right? Let alone when I do this two-way thing, now I can get a grandfather paradox going because now I'm in my own past, right, with this signal. So that's a problem. And so this is how any and all faster than light travel communication, very easy to see on this graph paper that it produces time travel. So hopefully this explains it for you. If you have any questions, you can go ahead and comment on this and ask them, and I can try and answer them. But this is just kind of it in a nutshell.